Let's discuss the process of selecting the correct conductor size when dealing with continuous loads and the application of derating factors. This involves several steps to ensure safety and compliance with electrical codes. The scenario involves three three-phase, 3-wire circuits, each applying a separate 45 amp continuous load within a racewire. The conductors are THHN with 75°C terminations. We need to determine the appropriate conductor size and overcurrent protection device, while accounting for the derating required due to having multiple current-carrying conductors in the same racewire. Firstly, calculate the continuous load current. Since the loads are continuous, we must multiply the load current by a factor of 1.25. In this case, 45 amps multiplied by 1.25 equals 56.25 amps. This is the minimum current carrying capacity the conductors must have before any derating is applied. Secondly, select the overcurrent protection device, or OCT. The OCT protects the conductors from overcurrents and short circuits. The code requires us to use the next standard OCT size above the calculated continuous load current. Since our continuous load current is 56.25 amps, the next standard OCT size is 60 amps. We will use a 60 amp breaker or fuse to protect the circuit. Thirdly, we select the conductor size. We use NEC table 310.16 to determine the appropriate conductor size based on the OCT and the conductor's temperature rating. The terminations are rated for 75°C. According to table 310.16, a number 8 THHN conductor is rated for 65 amps at 75°C. This value is determined before applying any derating factors. It's crucial to understand that the initial conductor selection is based on the OCT and the temperature rating of the terminations without considering derating at this stage. The 65 amp rating of the number 8 THHN conductor is sufficient to handle the 60 amp OCT. Fourthly, we apply the derating factor. Because there are 9 current-carrying conductors in the raceway, a derating factor must be applied to reduce the allowable ampacity of the conductors. The derating factor for 9 current-carrying conductors is 70%, or 0.7. We multiply the conductor's ampacity by this derating factor to determine the derated ampacity. In this case, 65 amps multiplied by 0.7 equals 45.5 amps. Fifthly and finally, we verify protection. We check if the derated ampacity of the conductor is still sufficient to carry the continuous load current and is protected by the OCT. The derated ampacity of the number 8 THHN conductor is 45.5 amps, and the continuous load current is 56.25 amps. Since we picked number 8 AWG rated for 65 amps before derating, and we are protecting it at 60 amps OCT, we are still in compliance with the NEC. The 60 amp OCT adequately protects the number 8 THHN conductor. Even after derating, the conductor is protected by the 60 amp OCT. It is important to note that we selected the conductor size based on its ampacity before derating and ensured that the OCT protects the conductor's derated ampacity. Therefore, using a number 8 THHN conductor is acceptable in this scenario. The initial ampacity of the conductor, before derating, must be sufficient to handle the OCT, and the OCT must protect the conductor after derating. In summary, the steps are as follows. 1. Calculate the continuous load current by multiplying the load current by 1.25. 2. Select the appropriate OCT, choosing the next standard size above the calculated continuous load current. 3. Select the conductor size based on the OCT and the conductor's temperature rating without considering derating at this stage. 4. Apply the derating factor based on the number of current-carrying conductors in the raceway. 5. Verify that the derated ampacity of the conductor is still protected by the OCT. By following these steps, you can ensure that conductors are properly sized and protected in accordance with electrical codes, enhancing the safety and reliability of electrical installations. If the derated ampacity of the conductor is less than the continuous load current, a larger conductor size must be selected to meet the requirements. The NEC provides tables and guidelines for determining conductor ampacity and derating factors, which must be followed to ensure compliance and safety. Consider another example to further illustrate conductor sizing and derating. Suppose you have a circuit with a continuous load of 40 amps, and you plan to use THHN conductors with 75°C terminations in a raceway with 6 current carrying conductors. You need to determine the appropriate conductor size and oct. Firstly, calculate the continuous load current. The continuous load current is 40 amps multiplied by 1.25, which equals 50 amps. Secondly, select the oct. The next standard oct size above 50 amps is 50 amps. Thirdly, select the conductor size. According to table 310.16, for 75°C terminations, a number 8 THHN conductor is rated for 55 amps. This value is determined before applying any derating factors. Fourthly, apply the derating factor. The derating factor for 6 current carrying conductors is 80%, or 0.8. We multiply the conductor's ampacity by this derating factor to determine the derated ampacity. In this case, 55 amps multiplied by 0.8 equals 44 amps. Fifthly, verify protection. The derated ampacity of the number 8 THHN conductor is 44 amps, and the continuous load current is 50 amps. In this scenario, the derated ampacity of the conductor, 44 amps, is less than the continuous load current, 50 amps. Therefore, a number 8 THHN conductor is not sufficient. We must select a larger conductor size. According to table 310.16, a number 6 THHN conductor is rated for 75 amps at 75°C. Applying the derating factor of 0.8, the derated ampacity is 75 amps multiplied by 0.8, which equals 60 amps. Now, the derated ampacity, 60 amps, is greater than the continuous load current, 50 amps, and the oct is 50 amps. Therefore, a number 6 THHN conductor is the appropriate size for this circuit. By going through these calculations and considerations, we ensure that the selected conductor can safely handle the continuous load current after accounting for derating, and that it is properly protected by the oct. This approach is critical for ensuring the safety and reliability of electrical systems in various applications. Remember, electrical codes and standards are in place to protect people and property from electrical hazards. Always refer to the latest edition of the NEC and consult with a qualified electrician or engineer for specific applications and installation. In addition to the continuous load and derating calculations, other factors may influence conductor selection, such as voltage drop, ambient temperature, and installation methods. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, a larger conductor size may be required. Ambient temperature affects the ampacity of conductors because higher temperatures increase the resistance of the conductor, reducing its ability to carry current. If the ambient temperature is higher than the temperature rating of the conductor, a derating factor must be applied. Installation methods can also affect the ampacity of conductors. Conductors installed in conduit or cable trays may have a lower ampacity than conductors installed in free air due to reduced heat dissipation. The NEC provides tables and guidelines for derating conductors based on ambient temperature and installation methods. When selecting conductors for electrical installations, it is important to consider all of these factors to ensure safety, reliability, and compliance with electrical codes and standards. By carefully calculating continuous loads, applying derating factors, and considering voltage drop, ambient temperature, and installation methods, you can select the appropriate conductor size for any application. This ensures the safe and efficient operation of electrical equipment and systems. The key to accurate conductor sizing lies in meticulous attention to detail and a thorough understanding of the relevant electrical codes and standards. It involves correctly calculating the continuous load, applying all applicable derating factors, and selecting a conductor size that can safely carry the required current while considering voltage drop and other relevant factors. By following a systematic approach and consulting with qualified professionals when needed, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable regulations. In addition to these factors, it is also important to consider the type of load being served by the circuit. Some loads, such as motors, may require larger conductors to handle inrush currents that occur when the motor starts. The NEC provides guidelines for sizing conductors for motor circuits based on the motor's full load current and other factors. Other types of loads, such as lighting, may have specific requirements for conductor sizing and protection. Always refer to the NEC and other applicable standards for guidance on selecting conductors for specific types of loads. Another important consideration is the type of insulation used on the conductors. Different types of insulation have different temperature ratings and ampacities. THHN, THHW, and XHHW are common types of insulation used for conductors in electrical installations. Each type of insulation has its own advantages and disadvantages, and the selection of the appropriate type of insulation depends on the specific application. The NEC provides tables and guidelines for selecting the appropriate type of insulation based on the operating temperature, ambient temperature, and other factors. Finally, it is important to properly terminate and splice conductors to ensure a safe and reliable electrical connection. Poorly terminated or spliced conductors can overheat and cause a fire. Always use approved connectors and splicing methods, and follow the manufacturer's instructions for installation. Properly torquing connections is also essential to ensure a secure and reliable connection. The NEC provides guidelines for terminating and splicing conductors, and it is important to follow these guidelines to ensure a safe and reliable electrical installation. In summary, selecting the appropriate conductor size for electrical installations requires careful consideration of several factors, including continuous load, derating, voltage drop, ambient temperature, installation methods, type of load, type of insulation, and proper termination and splicing. By following a systematic approach and consulting with qualified professionals when needed, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable regulations. Understanding these principles is crucial for anyone involved in electrical work, from electricians and engineers to building inspectors and homeowners. By mastering these concepts, you can contribute to the safety and reliability of electrical systems in homes, businesses, and industries. The NEC is a comprehensive document that provides detailed guidance on all aspects of electrical installations, including conductor sizing, overcurrent protection, grounding, and wiring methods. It is essential for anyone involved in electrical work to have a thorough understanding of the NEC and to follow its requirements carefully. The NEC is updated every 3 years to reflect changes in technology and best practices, so it is important to stay up to date on the latest edition. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with your local building department or electrical inspector to determine the specific requirements for your area. By following all applicable codes and regulations, you can ensure that your electrical installations are safe, reliable, and compliant with the law. Electrical safety is paramount, and it is important to take all necessary precautions to prevent electrical hazards. Always work with qualified professionals and follow safe work practices when performing electrical work. Never attempt to perform electrical work if you are not properly trained and qualified. Electricity can be dangerous, and it is important to respect its power. By understanding the principles of conductor sizing and following safe work practices, you can contribute to a safer electrical environment for yourself and others. This discussion covers the fundamental principles of conductor sizing and derating, but it is important to remember that every electrical installation is unique and may require specialized knowledge and expertise. Always consult with qualified professionals and refer to the latest edition of the NEC for guidance on specific applications and installations. By staying informed and following safe work practices, you can ensure the safety and reliability of electrical systems in all types of environments.